So my name is Will Sargent. I'm giving a talk on security in Scala. Specifically, I'm giving a talk on how you implement security features in Scala using Scala-specific types and using data structures. So this is very much a talk about what sort of things you can do in Scala that make your application far more secure in general, even if you're not necessarily looking to, protect against an XSS attack or be able to render an HTML, website or worried about Kafka, etc. These are still useful techniques. So there are many new things here. I will leave some time open for questions at the end, but don't be worried if a lot of this is completely new to you. I do have a guide up, and I also have manuals and examples and things that actually go into much more detail about all of this. So this is going to be high level. However, this is going to be a fun ride. So what is security in Scala? And the way I'm defining security for now is just at a very high level. We are going to validate untrusted input. We're going to hide internal state and behavior. We're going to deny functionality to attackers. So what all of that means is for any application that you're going to use, you're going to be using these basic techniques. You want to make sure that whatever you're doing, nobody else can do it unless they're supposed to be able to do it. And you want to make sure that no matter what, you're not taking something that somebody gives you for granted. You're checking everything on the way in, you're checking things on the way out, and you're denying functionality to people who you think look suspicious. So the sort of decisions that we make and the sort of design that we do in object-oriented programming, a lot of this is actually inherently security decisions from the point of view of saying what it is that we want to expose, what it is that we want to hide. So we talked about validation. Well, that is an essential part of programming. We talked about deciding what is visible, that's abstraction. We talk about deciding what's hidden, and that's encapsulation. And then we talk about access control. That is all about taking something that was working and turning it off. And then the security tools that we have for doing a lot of this stuff, we actually have more than are commonly used. So one of the things I'm going to show you here is refinement types. Those are used for validation. Capabilities are used for abstraction because they show you how to do one specific thing. Encapsulation, because they hide everything that they're not showing you. And revocable access, in that you can actually turn off the spigot. There's another feature called dynamic sealing, which allows you to encapsulate and hide information and data that you don't want to be passed around to anybody else, while still being able to work with a reference. And then we have membranes, which are a fun feature, which allow you to have operational isolation. So they allow you to apply a policy over multiple objects and multiple references. So starting off with refinement types. What are refinement types? Well, they are literally raw types that obey a predicate. That is, they will obey rules. You know that when you're looking at this kind of thing, when you're looking at something that's a refinement type, that it already jumped through the appropriate hoops. So you've got examples of raw type here. Wait, do you have a laser pointer? I don't think that shows up. Okay. So an example of a raw type is string, boolean, character, int, and the collection API. These things are unconstrained. They could contain anything. So, obviously a boolean contains true or false, but what does an integer contain? If you're asking for an age, it could be 0 to 100. So you could be handed like -17. What does that mean? String in particular is evil enough that we have stringly typed APIs entering the lexicon. Because you can pass anything into a string and it's still a string, it's still valid. So if somebody decides to pass in the first chapter of Moby Dick, well, that's really on you. So there is a library that's already in Scala for dealing with this. It's called Refined, and I encourage everyone to download and check it out. And it implements refined types in Scala. before you actually have a request parameter come in here, and you want to say, I think this is a zip code, but I'm not really sure, because you've got a string here. You're not really doing any validation on it, or even if you do, you still got a string at the end. What you want to do is turn stringly typed code into strongly typed code. And so what you can do here is you can specify, I've got a string, and I'm going to refine it by applying this predicate. I'm going to make it match this regular expression here, which consists of 5 integers. And then once you have the zip code, then you can say refine v, and it passes you back an either with either string or zip code. So you can see here we're running it through tut. We've got something that's a string. We run it through and we get a zip code out here. You only get access to this type if it validated correctly. So you can't really get it wrong. If you pass it through refined v here and it didn't actually validate as a zip code, you get back a string containing the error message. Okay? So that's the first step, is we can validate our input such that we can constrain and narrow and ensure that input follows some checks. Now, this isn't going to cover everything, because it isn't going to cover things like, is there a duplicate of this email? Or does this implement this kind of behavior which is time specific? So, after this date we actually changed this policy and it's no longer valid. It won't handle the big cases, but it'll certainly handle the small ones. So you can't get a refined code, you can't get a zip code without going for refined. You can pass a zip code anywhere around, you can pass a string, and you can nail it down. So next we come to capabilities, and capabilities are a security primitive that confers authority by reference. And we'll go into this in more detail, and I'll show you some examples here. But for now, you just have to know if you have a capability, then by definition, it gives you authority to affect a resource in a specific way. And what do we mean by capability? What do we mean by authority? What do we mean by resource? Well, in Scala, a resource is an object that has sensitive fields or methods. We know that it has the goodies. We know that we want to get to the goodies. And with a capability is the only way to get to those goodies. So a capability is a reference to an object. It doesn't have to be the resource specifically. That can affect a resource, that can affect that resource in a particular way. So that's different from object-oriented programming, because when we're talking about object-oriented programming, it's really fundamentally about abstraction. It's all about saying, we've got a cake, here's an eat method, you can eat this. And then finding out different ways that you can hook things together. Capability is actually kind of the inverse of that. It says, there is a cake, absolutely, but you don't have access to it. We're not giving you a reference to this cake, so you can't eat it. There's no way you can call the eat method on this cake if you don't actually have a reference to it to begin with. So just to give you an example, here we've got a capability. We've got a document object that has a field that anyone can change. So it's a var that we just stuck in a case class. And we want to expose the ability to change the name as a capability. So we have a document here. We have the var. We have called Steve, and we're just going to call it Will. And that's just as simple as it gets. So what we do here is we take the document, we make this private. We create a private object capabilities internally here. And we say, we're going to expose this change name such that we can actually change this guy through this guy. So because this is a private object, nothing external to this class or to the singleton object, the companion, can actually touch this guy. So if you try to look at a document by itself, there's nothing you can touch. You can't change the name because you don't have, the access modifier won't allow you to do it. And the definition of change name, the name changer, is it's an abstract, it's just a trait. It calls change name. We have taken a string, we pass out a unit, and we see here that we've got a companion object, and we've got a name changer which gives us access to it. So what this does is, because this isn't in a class, because it's a companion object, it has access to the private field. It has access to the private field object, rather, capabilities, and it can then get to the name changer. So this provides you with access to expose a capability, but this access itself is typically sealed. So what this means is you have a document, and then you set up access, and if you call access name changer, then that gives you a name changer for that document. Then you can call change name, and that changes the name to Will. And then once you print it out, then you've got it. Now notice here we've got name changer, but we don't know that this is necessarily connected to this resource. So this is, functional programming in and of itself, in that this functionality can be completely abstracted from the resource and from the access itself. You can take this and you can send it wherever you need to get the work done. And the only thing it will ever be able to do is change the name. It can't do anything else. So the name changer can affect the resource. Access to the resource itself doesn't mean you have capability. I mean, technically you could implement it as a trait. The only way to get access to the name changer is through access, which is sealed. And note that this is a root level capability. We can't actually revoke this. So if you're passing this out to something and you want to be able to take it back, that is, you want to turn something off, then you'd usually use revocable. So sealed and revocable are concepts that we will get to coming up in the next couple of slides, where we'll go into a bit more detail. All right, so that's the general case. Now, more practically speaking, you're going to be looking at a CRUD repository. You're going to be looking at something which has a whole bunch of available methods. So looking at the item repository. Item repository, we allow anybody to create, read, update, and delete any item. And there's no real benefit for us to be able to allow anybody to do that. In fact, we'd rather be able to know exactly who has the ability to delete things, what's happening to read things, and we may want to actually have logging and auditing and what have you attached to various different capabilities. So we want to split this up so that this is actually far more fine-grained. So if an operation has no need of delete functionality, we're not going to give it. So while we're doing that, let's make functional effects part of the API because we're try hard. Okay, sorry, not sorry. And so item repository, here I'm just doing the finder and updater methods. So instead of having a CRUD repository, we are doing find and update. We're not doing delete and the other one. So we've got this simple thing here. We've got tagless final on the other end, so we can turn this into either the thing itself or a try or a future if we need to. We've got the same kind of pattern. And we've got an item repository implementation here, which goes through, these methods are private. I've just stuck this into a seek where it finds it for now. And then we have a finder with ID, which actually just returns the raw thing itself. So technically, this could still throw an exception and cause side effects and what have you. But there are ways around this. So when we actually invoke item repository here, invoking the item repository, we do the same thing. We create the resource, we set up access, we ask for the capability that we want, and then using the capability, we get the thing that we actually wanted. So here we're returning the item, but we're not actually going through the resource. Okay, make sense so far? All good. All right, so now we've got item repository with effects. So what we can do is, instead of throwing an exception, because we're calling a repository and that talks to a database, and databases throw exceptions and we lose connection and things like that, we want to actually wrap some behavior around that. So what we can do is we can say we've got a try access here. It's going to take the original access. We're going to say this finder takes a try, and then we're just going to wrap this functionality around the try block and here. And then we just have the same kind of thing. Instead of doing an access, we do a try access. And instead of when we do a finder here, we get back a try option item. Okay? So finders, capabilities, because they are very small units of functionality. And because we can control the effects of capabilities extremely well, they actually are an extremely good matchup for functional programming techniques, precisely because you know exactly what's coming in and what's coming out. You're not simply passing around this big ball of behaviors. You're very carefully targeting what you want. Now, earlier I mentioned if you're handing something out and you're passing it out from an access, it's a root level capability. Usually when you are delegating something to somebody, you are doing it in the context of a lifetime. That is, if somebody logs in, then that person obviously has the right to change his or her own password. And you want them to be able to do that only as long as the user's session is actually active. So a capability, you're looking at that yourself, like it doesn't actually tell you when somebody's logged out. So what we can do, rather than simply hand them a raw capability, is we can call something called a revoker and wrap it in something called a revocable. And we can get back a proxy, which as long as a revoke method has not been called, will forward the original argument onto the original capability. But if it's actually been revoked, then every time you call it and you try to do something, it will throw a revoked exception. That pathway through to the original capability is no longer good. And this is where we come to the library that I just made public, like about an hour ago. So I've got a OCAPS library that implements revocable and revoker and a whole bunch of utility methods, which do all of this for you and set up a bunch of macros to hand up the boilerplate. So a revocable example, here we're importing the library. We say we've got an item repository finder, and we're going to say we want to be able to revoke this at some future point. We get back a revocable, which hands us back the proxy and the revoker. And we can then call revoke down here. And then once we call revoke down here, once we call find, everything after that will throw an exception. So the interesting thing about capabilities is that they're essentially functions with lifecycle attached. And it's one of those few cases where you actually do want a side effect, and you do want to be able to have things blow up and, at any moment's notice, because failure can happen, and when that happens, you go out and you ask for another capability again, because you're locked out. So that is one. Revocable is by far the most commonly used way of working with capabilities, but it's not the only one. There's a lot to go through, and each of these has their own means and uses and background to it, and all of that is set up in the manual, in the capability guide. We've got composition. We take two capabilities and we squish them together so that they're actually returns a compound type. We can do attenuation here, where we actually take something that has been squished already and we say we want to pull out one single capability. We can do modulation, where we say we've got something that's a doer here and we want a before and after method to be called through it, and it looks the same to us. And then finally we've got expiration, which says this is a capability which we're handing out, which has some policy which after it happens, the capability is revoked. So that could be count based, it could be timer based, it could be you look suspicious based. So here we've got an example saying we've got a revocable. We are saying that this is doer, and if this, before we call any particular method on this doer, we check to see if the deadline's overdue, and if it is, then we just revoke it. So when you're handed this guy, this expiring doer, there's no way around it. If you are handed this thing and it's past the deadline, you're done. You have to ask for another one. And this is particularly useful in situations such as ACA workers, where you're passing around messages, or things that might have a time of check, time of use attack, where somebody actually gets the credentials, but then somebody else was actually recording those credentials at the same time. Like, that there is a wireless garage door opener attack, where like if you push the button and somebody's actually listening in, they can record it and they can actually play back the same thing like several days after you've actually gone through and left the building. So this actually limits that, because you can say you have the credentials for the next 30 seconds. If you didn't do it in the next 30 seconds, you're probably an attacker, because we want that thing to go. So that's capabilities. But we still have to talk about how we're going to get capabilities working through with everything else. That isn't a capability, because once you've got a capability, you have to be really careful about how you're handing it around. And we've got these things, like we've got actor messages, where we're just passing them through and anything can look at the event stream. We've got dependency injection frameworks, where we stick everything in a bind and you can pull it out by the type, by the class. And so what we want to do is do dynamic sealing, where dynamic sealing wraps an object in another class, in another object, such that it can't be seen or tampered with until it's unsealed again. So what this means is it's sort of like having private, but you don't have to say I'm in a containing class in order to be able to get it. You can actually choose your siblings. So you have a sealer and you have an unsealer. And the sealer wraps something and returns you a box, so it returns you a sealed box of string. And then you have an unsealer, which takes a box of string and returns you the value. And depending on how you arrange the sealer and unsealer, you can get various different effects. The vastly most fun thing out of it is that you can get you can ensure a lot of behavior that you would otherwise have to do with PKI. So you can do encryption, signing, and so forth. So it's a very old idea. It's actually like from 1973, but it is something which sort of takes a little bit of getting used to, because when you're actually creating a brand here, so you've got a brand, we've got a string here, this is actually used for like creating the box. We've got a sealer and unsealer, we seal foo, and we have a sealed box, and then we call unsealer, and we get string as foo again. So this allows us to do things like rapid database connection, because nobody needs to be able to get root level access to a database connection, because it just makes a mess of everything. We can use it to wrap access objects, so that if you have something which returns a capability or gives you access through all of the capabilities, all of that can be wrapped in something that is sealed, and then you keep the unsealer in a very safe place where only one thing can get to it. You can do signing if you make the sealer publicly available. So you can say this is a result, and if I want to check this, I can see that this particular object over here was the one that produced it. And you can also do encryption, where you can say anybody can send me anything and do so securely. Here is the sealer. Go ahead and seal this and send it to me. So just to give you an example here, we've got a slightly more advanced case. We've got food, and we've got can, and we've got a can opener. And so the sealer here is something which is implicit in a lot of this, because we don't see it during normal access. We create the sealer and unsealer to say we're going to create a box of food, and we're going to create a can opener here. We create a can of spam, which then we can see is actually sealed here. And then when we open the can using the can opener, we can see that the food is spam. So it just gives you an idea of how you would pass around sensitive information, say credentials, that you would only want two particular objects to be available to. So that brings us to the last one, which is membranes. And membranes are a fascinating concept. They are something which initially you sort of look at and you're like, I'm not sure I understand this, because the definition is it's an extension of a forwarder that it transitively imposes this policy on all references exchanged through the membrane. And you might be thinking, wait, what? So the best way to explain this is, imagine that you've got a future of A and a future of B. And then you know what you do if you want to get from one to the other. You call flat map. A membrane is something which wraps everything such that you think that you're actually you're working with A and B. But what it actually does is it calls flat map for you. So every time you think you're working with the raw objects, you're actually working through this thing. Okay? And it's not precisely that, because it is actually based on message passing and dynamic languages. And so it's not necessarily something that's easy to work into the JVM. So all methods are wrapped in a membrane, they can't escape. It's commonly used in sandboxes, like you see this in browsers a lot, where they basically have JavaScript that can run, and then they have the browser internals. But because the membrane and the capabilities that are exposed to the browser and the JavaScript are all very carefully separated, that is the mechanism by which you manage to avoid having JavaScript dig into your browser guts and display a calculator on your screen. So it's used for uncooperative revocation. The best way I can think of to actually do it in the JVM is using a byte-buddy interceptor, which allows you to modify the bytecode under the hood. So that's if you're uncooperative. But fundamentally, type safety doesn't really mix well with message passing because they're not the same, they don't look the same. You could probably do it in actor actors if you got rid of actor selection or are willing to not use it. This is, again, something which if you're running somebody else's code and you're doing it in a sandbox, I'm not sure I'd necessarily recommend this. If you're running your own code and you're just basically saying, I know that the actor will do this, that, and so forth, then having something basically being able to send messages backwards and forwards, even to unknown actor peers, is probably okay. However, because we actually talked about future A and future B, and we talked about flat map and all of that stuff, I'm not saying that a membrane is a dependently typed monad, but a membrane's a dependently typed monad. So if you're willing to deal with working with an effect up front and you're willing to wrap everything in that yourself, basically you're doing cooperative revocation, then OCAPS has a permeable membrane that has the same effect. So just to give you an idea of how this works, say that we've got two capabilities here. We've got a locale reader and we've got a time zone reader, both of these using tagless final. And then we've got a location. We're just going to implement these by pulling out the thing, so we've got a locale, we've got a time zone, and pull that thing out. And we've got a permeable membrane. So a permeable membrane works exactly the same way that we're talking about the tri-axis before. Only instead of working with the tri-axis, we're now working with a membrane axis because we want the membrane effect. So we've got a wrapper. That wrapper is actually a dependently typed, a dependent type of the membrane itself, and it has map and flat map internally. And so anytime that we're actually calling the locale, we just want to say we're going to wrap this, and then we're going to return a wrapper of locale and a wrapper of time zone, and so a wrapper of foo, etc. And what this means is we have a location here, and we want to say that this has membrane access in here. And then once we've actually got the membrane access, this is a revoke membrane, so we know that we can call revoke on this. Then we can run through all of this stuff. We can say that we have a time zone formatter, and we can stick that into a wrapper. And then we can say we want to pierce the membrane, and then it returns as a formatted string in that particular time zone. So alternatively, if we want to revoke it, we do exactly the same thing, but we call revoke, and then we can see that piercing that membrane causes a revocation immediately. So this allows us to be able to do functional composition and capability revocation through flat map monad things. So the question is, if you have a million capabilities to grab or revoke, how do you manage that? That is a very good question. The answer is that you don't deal with the raw. So going back to the very first slide, A capability is a security primitive. And because it is a security primitive, you have to build from the ground up. So typically what you would do is you're not working with the lowest base level reader and writer. So you have a finder and you have an updater on the item repository, for example. Instead of actually handing out a finder and an updater to everything that wants it, you would have things like a password updater, which goes out, finds the user, and then, if it's found the right user, updates that user. So that password updater takes a finder and an updater, but that isn't exposed. So you work up the domain to your domain operations, and then the domain operations that require finer-grained capabilities downstream, in turn have those. So you have to expose like your fine-grained capabilities, but then after that you wrap them up in a domain, and then you expose them at the granularity that is convenient for you. So a REST application, for example, has like, can you call this REST method? You can't call it, like if you don't have this capability, if you can't execute on it, it doesn't matter exactly why. Like it doesn't matter which capability failed or which capability was revoked. All you care about is I couldn't change my password. Great, I hope you enjoyed the talk. Thank you.